So a matrix is basically just an array of numbers. There's no letters involved in matrices. Okay, it looks like a little grid. There are rows and columns. So this is an example of what a matrix would look like. It's defined as a rectangular array of numbers with m number of rows and n number of columns. And the first thing we're going to learn to find is the order of the matrix, which is also called the dimensions of a matrix. Just like length and width would be the dimensions of a rectangle, rows and columns are the dimensions of a matrix. So we would do the number of rows, and then the little x is read as by, just like a 2x4, or like that x is what is that? And then the number of columns. So you're not actually multiplying them out. That's just how it's read. So rows go like horizontal, columns, if you think about the columns like holding up a building, right? The columns would run top and bottom. If you think about it in terms of like a numbers or an Excel spreadsheet, same thing. These are rows, so there's 1, 2, 3 rows here, and then there are 1, 2 columns. So the order of this matrix, or the dimensions of this specific matrix, would be a 3x2. So in the beginning, it's just going to ask you for the dimensions, and then eventually, specifically when we get into like multiplication of matrices, you'd have to know, and it's important to make sure you do the rows, then the columns. So example 1 just says, find the dimensions of the matrix. So we're counting number of rows and then number of columns. So if you're looking at A, how many rows are there? 2. How many columns? 4. So this would be a 2x4. B, how many rows? 3 columns? 1. So it's a 3x1.
So you would never like do 2 times 4?
No.
It's always just
that, yeah. Yeah.
Is it technically incorrect if you put the
columns first?
Rows?
Yep.
Okay.
Yeah. Has to go rows then columns. And not like, I mean, obviously right now we're just giving this, but when we get into multiplying matrices, you have to be able to match them up. So you have to put it in the right order. All right, so an augmented matrix is taking a system or an equation and then writing it in a matrix form. So we're taking these, which is kind of like baby stepping our way into our eventual goal, which would be to solve this system using matrices. So you just rewrite it without the variables. The first column is always the x's. The second column is always the y's. The third column is always the constants. If there was extra, so if there's a third variable, it's z, just like our 3x3. And then don't ask me why. Somebody got drunk when they decided this one. It goes x, y, z, then w. If there's a fourth variable. I don't know. I'm sure there's some reason. I don't have time to look it up. Maybe when you're bored later. Feel free. There we go. Braden's on it. Okay. X, Y, Z, then W, then the constant would be if there was 4 variables. So the constant always goes at the end. The sign goes with the number. So if I was to take this and create the row in the matrix, it would be -2, then 3, then 7. And then if I was to create the row from this, it'd be 5, then -4, then -10. The proper way to put this would be in a brace. So it gets a bracket at the top, at the bottom like that. And sometimes you'll see it like this, and sometimes you'll see 2 little dots here, which indicate that's where your equals goes. So it's not right or wrong to put them. You don't need to put those 2 little dots, but sometimes you'll see it with the 2 little dots and just know that's what it means. It's still the same every time. The last one should always be the constants. All right, so now we're going, for the first one, doing what we just did, taking the systems of equation and writing in a matrix form, and then B, we're going to do the reverse. So what's my first row for A? -1, right? 10. Good. Second row? Good. Good. And again, you could put the little colons in there. You don't need them, but you could if you want to. Now we're working the other way around. So now I've got the matrix. What does it say? Wait, let me pause. All right, so now we're going from the matrix to the system. So remember, the last column is always the constants. Okay, and then there's 3 variables here. So these are the x's, these are the y's, and these are the z's. So I'd get negative 7x plus 2y plus z. You can put a 1 there if you want, but you don't need it. Equals 4. And then 5x minus 3y. This could be plus 0z, but really that would be a space. Equals 15. You don't have to leave the space. I mean, think about it. If we were to do these, I mean, you're going to see in a little bit. You're going to be able to take these and then put them in systems and then do back substitution like we did before. So you don't need this space at all. Just remember that there's no z there. All right, so these are all the things you can do with a matrix and the rows of the matrix. You can switch 2 rows. So I could switch row 1 with row 2 with row 3. You can move them around like that. The whole row moves though. You could multiply a row by a non-zero constant. So I can take everything in row 1 and multiply it by 5, as long as I do it to everything in that row. 0, not, because it would get rid of the whole row, right? So that's what it means by non-zero constant. And you could add a multiple of a row to another row. So I can add 2 rows together. I could do row 1 plus row 2, or I can add a multiple of one of those rows. So I could do like row 1 plus 2 times row 2. And that's the notation we're going to use. So this is matrix notation, right? Row operation notation, really. The arrows with both directions is the switch. So if I'm switching row 1 and row 2, I would write row 1, arrow, double-sided, row 2. That means I physically took all the numbers that are in row 1 and switched them with all the numbers in row 2. If you're going to do, multiply by a non-zero constant, it would be like 2 times row 1. You could do negative 2 times row 1, negative 1 times row 2, anything like that. You could do a fraction times a row. And then 3, add the multiple of the row. So if I'm just adding 2 rows together, like row 1 and row 2, I would do that. If I am going to change a row and then add it, I would do it like this. Row 1 plus 2, row 2. You cannot subtract rows, but you would multiply by -1 and add. You cannot divide rows, but you would multiply by the reciprocal. So the wording is what you just can't do dividing, but you can multiply by a reciprocal, and it does the same thing. So this one just says to identify the elementary row operation being performed to obtain the new row equivalent matrix. So it's taking my original matrix, changing it in some way, and it has to be some of the ways that we just said. You can do more than one thing, but it can only be those things, to change it to this new one. So you've got to figure it out. It's kind of like a puzzle. You got to figure out what they did. First row didn't change, right? So I know it's not just something like row 2 times row 1. First row didn't change. And we didn't swap. So I can rule out those 2 things. Second row did change. But these are not multiples of these, right? So I didn't just multiply by a number. Which means my other option is what? I could have added 2 rows together. If I straight up add them as they are, I would get 5, 3, and 7. So it's not just addition. Which means I had to do what? Multiply something by something and then add. So let's see if you see it. Multiply what by 4? Bottom by 4. Let's try it. So 12, -4, and 8, plus 2, 4, and 5. I get 14, 0, 13. Good job. So the way we would write this is row 1 plus 4 times row 2. You could also write 4 row 2 plus row 1. Order there doesn't matter because it's addition. All right, this one takes it a step further. Fill in the blanks using the row elementary operation to form a new row equivalent matrix. So now you're taking your first, go to your second, you're figuring out what they did, and then you're doing it to the missing space. So what's the difference between the first matrix and the second one? Second row is being multiplied by? Well, specifically which one? 1, 5. 1 over 5. Good. So this would be 1/5 is how we would write it. 1/5 row 2. Because we can't divide, we multiply by the reciprocal. And so this whole thing gets 1/5, which is why there's a 1, Why? There's a 7/5, and so that missing space would be what?
-2.
Good, -2. Questions on that one? All right, so this is our first goal, is to get these matrices into something called a row echelon form. Row echelon form, by definition, says that any rows consisting of entirely of zeros have to be at the bottom. So if I have one row that has all zeros, has to be the bottom row. The second thing is for each row that does not consist entirely of zeros, the first non-zero entry is 1. So what this means is if I'm looking at my rows from left to right, the first number that is not a 0 has to be 1. So the leading number as moving from left to right, here, 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 has to be 1. The third thing is for two successive, which is not successive, one after the other, non-zero rows, the leading one in the higher row is further to the left than the leading one in the lower row. This means that diagonal is formed. So you have to have, in simplest terms, row echelon is a diagonal of ones starting at the top left and working its way down with only zeros in front of it. So if you start, this would be row 1, column 1. That's what that cell is. So that's what these little numbers mean. The first one is the row. The second one is the column. So if I'm looking at, this would be row 1, column 1. Row 1, column 1 has to be a 1. Everything in that column, or in that diagonal, has to be a 1. And then everything to the left of it has to be a 0. All the rest of these are going to be numbers. They could have a 0 in there, but they could be any numbers. Even fractions could be in there, okay? But to the left of my diagonal has to be zeros. This is called row echelon form. We're going to basically learn how to get a matrix into that form. This is REF, row echelon form. Reduced row echelon form, so we have an R, and on the calculator, maybe I will show you that today. On the calculator, it is RREF, whereas on the calculator, this is RREF, reduced row echelon form. Still have your diagonal of ones, but now you have a 0 above and below that diagonal. The last one is your constants, so those will be numbers or fractions.
Does the, I don't know how to say this, but do you always have to have like the same number of zeros in the bottom, in the top as well? Or that is
For reduced row echelon, yes.
okay, so if you have like
It will happen though. Like you'll have, this would be a 2 row, 3 column matrix naturally, which would be a system from two variables, an X and a Y. And then your goal is to get the diagonal with a 0 above and below. Is that what you mean? Like the 0 above, there's 1 0 above, there's 1 0 below?
Yeah.
So for reduced row echelon, it's the same. Yep.
Okay.
And then for a 3 variable equation, you still want a diagonal of ones, and you need the zeros above and below. So there will be an equal amount on either side. Yes. And then the last column is always the constants. So the goal here is, if you think about it, if I took this back into matrix form, which we're going to do, into systems form, this first row would be X equals a number and Y equals a number. So you've solved the system. This would be X equals a number, Y equals a number, Z equals a number, and you've solved this system. So that's reduced row. In row echelon form, you'd end up with a triangle system. So like if you think about it, there were numbers here. So I'd end up with one equation with 3 variables, one equation with 2 variables, and one with 1. And we do that back substitution where we take the one with 1, plug it into 2, take the one with 2, plug it into 3. So you're creating from row echelon form, you're creating a triangle system. From reduced row echelon form, you have your answer already. So this one just says determine whether the matrix is in row echelon form, and if it is, determine whether it's in reduced row echelon form. So this one is not, it's unusual because you have your row of zeros. That doesn't always happen. It's very infrequent. But if you do have a row of zeros, where does it have to be? At the bottom. So it is, right? If that was in the middle, then there's a problem. So then the next thing I'm checking for is, do I have a diagonal of ones, not including the zero, because the zero could be there, with only zeros below it. Disregarding the row of zeros, right? Because this can happen, but it has to be at the bottom. So if you look at ignoring the row of zeros, do you have a diagonal of ones with the zero below?
Yes.
You do. So this is row echelon form.
But would it be like, is the zero at the top too?
Now that's reduced row echelon. Are there zeros on the top and the bottom? Oh, let me do it a different color. Are all of those zeros? No, so it is not reduced row echelon.
But I thought you only needed 1 0.
No, that's if you only have two variables. If you have three variables, you need a diagonal of ones or zeros here, because the zero is okay. And for row echelon, you're looking for these three to be zero. For reduced row echelon, you're looking for these three and these three. Everything above and below that diagonal. So basically everything except for that last column.
And you can have a row of like 3 zeros with the variable, and it doesn't matter where it is, as long as the one with every single zero, that always has to be
3 zeros actually would be a no solution matrix. Because you have no x, you have no y, you have no z, and you have a number in the last one. So you're saying 0 equals 5. So that's a special case. 0 equals 5 is a false statement. This whole thing is no solution.
Okay.
But if it's just asking you if it's row echelon or reduced row echelon, for right now we're just looking for that pattern.
Okay.
So if that was in the second column, it's fine. It's no solution, but it's still fine. Yeah. All right, now we're going to write this in row echelon form. So I'm going to give you some steps. For me, my first goal is get a 1. In the row 1, column 1 location. So this is the top left corner. If you can do this, it makes everything after this easier. Doesn't mean you can always do it, but it does make it easier. So my goal would be to get a 1 in the very first location, row 1, column 1. So it would look like this. 1, number, number, number. And then you've got all these other numbers here. So that's my first goal. I get that 1. Then I want to work my way down with the zeros. So I work my way down and across to get those 3 zeros. We'll talk about how to get that in a second, but that's the second goal. And it's really 3 steps. Then finish out your 1s. So then I work my way up here. These feel very overwhelming at the beginning, so I want you to take a deep breath because this is going to come with practice. And it is not always the easiest to do it exactly in this order. This is a suggested order. It's not like you have to do it this way. There are times when it might be easier to get a 1 before it is to get a 0. And we'll talk about that. But you got it. These are like, once you start the pattern and you understand like, okay, this is where I got to go, you get there. These take a lot of work sometimes. Sometimes they're super easy. You might do a completely different way as somebody else. It's kind of like the row, the new 1, new 2 process where it takes a little bit of time. But once you practice this, it will be easy. These are also tedious, which means you have to be very careful because you're writing a lot of stuff. You're rewriting matrices, you're changing them, you're rewriting them. So one lost negative sign along the way Messes the whole thing up. Okay, so now let's look at what we've got. First of all, what was our first goal? The one in the top left. Is it already there? Yes. Let's pretend it wasn't. Let's pretend row 1 and row 2 were switched. You can switch them, and then you can get row 1 in the top left corner. Does that make sense? People go, okay, negative 2's here. I'm going to multiply this whole thing by negative 1/2 to get a 1 in that, which works for the negative 2, but then you got a fraction here. I don't want a fraction before I need a fraction. So always look to see if it's not a 1 and they're not all divisible by that term, can you switch? I switch first if I can, okay? So that first goal was to get a 1 here. And the reason that that's my first goal is because I want a 0 here now. And if I have a 1 where it is, all I have to do is multiply that by the opposite of what's in that second row, and it's going to give me the 0. So in order to cancel with negative 2, I need the top row to start with a what? A 2. I need it to be the opposite of negative 2. Does that make sense? So that when I add these two, I get 0. Does that make sense? Yeah, okay. So I'm going to multiply this whole thing by 2. And then I'm going to add it to row 2. So my row notation is 2 row 1 plus row 2. You want to get in the habit of writing out that notation, because especially when you're getting assessed on this stuff, you have to give me that. Like if you just give me a page full of numbers, I cannot follow it. You're going to tell me what you're doing each time. So not only is it for me, but it's also for you, because if you get to x, and x is 731 over 17, you know you did something wrong, and you're going to go back through your steps, and you're going to say, okay, in this step, I did 2 times row 1 plus row 2. Did I do that right? And then you can check yourself, okay? So I'm going to take row 1, and I'm multiplying it by 2. This is going times each term here. So 2, 2, 0, 10. This is one of those go slow to go fast moments, because you got to be slow and careful. Then I'm going to add it to row 2, which is this one. So negative 2, negative 1, 2, and negative 10. And I add these. I get 0, 1, 2, 0. Now when I add 2 rows together, I can replace either row with that row. So I just added row 1 and row 2. I can actually take this sum and I can replace row 1 with it or row 2 with it. But what were we trying to do? We're trying to replace row 2. So I'm going to replace row 2 with it. So row 1 stays the same. 1, 1, 0, 5. Row 2 becomes 0, 1, 2, 0. Row 3, 3, 6, 7, 14. Now I'm working with that matrix. My first goal, get the 1, got it. Second goal, get the 0, got it. Third goal, get the 0 here. Is there anything I can combine with row 2 that's going to cancel out that 3? Is there ever something you can multiply 0 by that's going to make it negative 3? No. So this next step, you'll always have to use row 1. Row 1 and row 3. Okay? So what do I have to change? Good. Negative 3, row 1 plus row 3. So everything in row 1 is going to get a negative 3. And then again, we distribute. So negative 3, 0, negative 15. And then 3, 6, 7, 14. And now we add them. 0, 3, 7, negative 1. And we combine row 1 and row 3, right? So we can replace either row 1 or row 3. Which one do we want to replace? Row 3. So it goes 1, 1, 0, 5, 0, 1, 2, 0, 0, 3, 7, negative 1. Now I'm dealing with that matrix. I got my 1, I got my 0, I got my 0. The next 0 I want is here. Now, can I use row 1?
Yeah.
If I combine these two, I can cancel out the 3, but what happens to the 0 I got? Let's do it. We would multiply by negative 3, right? Don't do this. Don't write it down. Just watch. negative 3, negative 3, 0, negative 15, plus 0, 3, 7, negative 1, and I get negative 3, 0, 7, negative 16. So I got this 0, but I lost that one, right? So when you do the last 0, you're always doing it with row 2. Row 2 has a 0 where I need it to be. Do you see that? So I'm going to use row 3 and row 2. What am I going to change so that row 3 in that 3 spot gets a 0? I'm going to do negative 3 times row 2 plus row 3.
Why can't you just multiply the whole bottom by 0?
Because then you lose everything. So you can never multiply a whole row by 0. That's on that slide it says non-zero, right? I know, right? Wouldn't that be nice?
Yeah.
You can't. I mean, you can, but you'll be very wrong. Yeah. All right, so I'm going to do negative 3 times row 2. So 0, negative 3, negative 6, 0, 0, 3, 7, negative 1. And I get 0, 0, 1, negative 1. Rewrite your matrix. I can replace row 2 or row 3 with that, but I wanted to do row 3. So I'm doing 1, 1, 0, 5, 0, 1, 2, 0, 0, 0, 1, negative 1. So I got my 1 in my top left. I got 3 zeros below. Now, normally I would come back in here and these numbers may not be 1s. We're baby stepping our way into that. This one was a little bit easier because they're already 1s. So my goal for row echelon, right, because that's what the direction said, row echelon is a diagonal of 1s with just zeros below, not necessarily also above. So that is row echelon form. So the questions, some of the questions on their homework are going to say, put it in row echelon form. Then this is what your goal is. This is what you're done. But why we do this, just the next step, which is what we'll really focus tomorrow on, is I can now take this and make it x plus y equals 5. This y plus 2z equals 0. And this z equals negative 1. And I can use my back substitution to plug this in here. I would get the y, and then I would take the z, or I don't even need the z in the top. I would take the y, plug it in here, and I would get the x. So that's the ultimate goal with row echelon, which is what we'll do tomorrow. Right now, you're just trying to get it into row echelon form. Yeah.
And last question, in the beginning.
It's a bold statement. You sure you're not going to have any more questions ever again?
You switch row 1 with row 2. Can you switch it with row 3? Or?
Yeah,
Okay.
you can switch them with any of them.
Okay.
Yep. Okay, so that goal is row echelon. If it had said reduced row echelon, then I would still do the same pattern. I would still start with the 1, work my way down, but then you've got to work your way back up here, and all of those have to be zeros too. So that's the difference between row echelon and reduced row echelon. The payoff on reduced, so you work more on the front end, on the matrix end, but the payoff on the reduced is at the end you get x equals y equals z equals, and there's no back substitution part. Yeah.
You said to get the last 0, you always have to use row 2.
To get this 0, you have to use row 2. Yeah, otherwise you lose the first 0 in that row.
Okay.
Yep. So I would say if you're getting, it's hard to write this and have you remember it. But with this one, you can use any row. You can combine any 2 rows to get that first one and the second. To get this one, you have to use row 1 and row 3. And for this one, you have to use row 2 and row 3. If you do it in that order.
You can switch rows on this, though, right?
Yep.
Because if, let's say the first row had like a 0 at the beginning.
Yep, I would switch it.
You could switch it?
Yep. If it had 2 zeros, I'd push it all the way to the bottom. Yeah. So So for tonight, you're going to stop here. 31, it says, perform the row operations to
go
solve
up
the
and
augmented
through
matrix.
42.
So it actually tells you what to do in these steps.
31, 35.
For the first one, it says add row
41
2
and
to
42.
row 1.
Through 42.
When you do
including
that,
42.
you want to replace row 1 with
and then
it.
stop. And then we'll do the graphing utility
Then it says
tomorrow.
add negative
and then we'll
5
do the
or negative
last couple
2
of steps.
times row 1
Yeah.
to row 2. And this time you want to replace row 2 with it. Multiply row 2 by negative 1/4. Multiply row 1 by 1/3. And you will have put this in row echelon form. So from there, you're going to get 1, a number, 0, 1, and then these numbers. It says to then solve the system. So I'm going to take this and make it x plus whatever y equals whatever number, and y equals a number. And then you're going to plug it back in to solve your system and actually get your x and y. That's all B. No, that's all A. Then it says, write and solve the system of linear equations represented by the augmented matrix, and then solve it, write and solve it. So when you write the original one, it's this, that's what it means. And then solve it. And it's saying solve it using what we already know. So if you solve it using elimination or substitution, that's what you're going to do. And C just says, which method did you like better? So C is completely opinion-based. Would you have preferred to do the matrix part? Would you have preferred your elimination or substitution? That's it. Okay? But it's the comparison of the two.